Assalamu alaikum. So I am learning digital electronics and let's see how to make this three-way switch. So I will make this three-way switch and then I will make the digital logic circuits here in the LOGISIM, or we can make that in the Proteus, or we can make that in online digital logic simulator. Okay, so let's start. So first of all, what this question is telling me about, assume that a large room has three doors and that a switch near each door controls the light. Okay, that means it is telling me that I have three persons here, 1 2 3, and they have three switches and I have one light. Okay, so let's say this is the light, this is the light, and now let's say light is off because three persons want that this light should be off. That means this 0 means the switch is off. Okay, now the last line saying me that it has to be possible to turn the light on or off by changing the state of any one of these switches. Oh, that means if the first person wants that I want to turn on the switch and the remaining persons as it is, then the switch will be on. Now the second person wants that I want to, this light is so irritating, so I want to make that light off, and this can be done by switching his switch, and the second person, if he switches on the switch, then the light will be off. Now the third person wants the light to be on, so what he will do, he will turn on his switch and remaining will be as it is, so the light will be on. Now let's say the second person wants that no, I don't want the light, so he make it 0 and the light again becomes off. So from this scenario I can see that when I have only one, then the light is on. When I have 2 1 like this, the light is off, and when I have 3 1, the light is on. So this is the scenario. You can see that in this case the light is on. For this case, when 2 1s are here, the light is off. 3 1, light is on. 2 1, again light is off. Okay, so this is the case, and now I will make a truth table. So let's say x1, x2 and x3 is the 3 person and the output is f. That means when 0 0 0, the output is 0. Then 0 0 1, 0 1 0, 0 1 1. Okay, let me write all the possibilities. Then 1 0 0, 1 0 1, 1 1 0, then 1 1 1. Okay, that means 1 1 means 1 1 1. 2 1, twice 1 means 0 0 0, and 3 1 means 1. Okay, so let me now make a logic here. So f will be equal to, you see the 1 is here, and here x1 and x2 is 0, so we have to write here x1 bar, x2 bar. Then x3 is 1. That means this thing will become 1 because 0 bar is 1, 0 bar is 1, and x3 is 1. So 1 1 1 means 1. Okay, again I will work with this thing. So I can see that x1 is 0, x2, x3 is 0, so we have to give a bar here. Now let's work with this thing. So x1 has bar, but remaining 2 has no bar. oh sorry, what I have done here, x2 and x3 has power. Okay, now for the last part, x1, x2, x3. So this is the expression for the output, and now let's make that in the LOGISIM. So I can see when I have x3 or x2 or x1, I have 1 and okay, so let's make that thing. So that means I have 3 inputs here. Let's make it to the south. Okay, now let's copy this thing because I have 3 switches here. Okay, so now let's make a long wire here. Okay, now let's insert some NOT gate like this. Let me copy this thing here. Let me again copy this thing, and then I will make a connection here. And I have to make a level here, so the level is x1, then this level is x2, then this level is x3. Okay, so now I have all the inputs and their negatives. You can see here like this. Now I need 4 AND gates. 1, 2, 3, 4. Actually I should delete this thing first and then make just 1 AND gate to input 3. So I'm making the input 3. Okay, so now I will make the logic circuit like this. So first x1 or x2 is negative and x3 is positive. Okay, that means x1, this x1 is x not, x2 not, but x3, and then I will make x2 with x1 and x3 not. Okay, that means x1 is not, oh sorry, so x1 is not, x3 is not, but connected with x2, and then I have to connect x1, so connect x1 and x2 not, x3 not, and then I have to connect x1, x2, x3, so x1, x2, x3. Now I have to sum all the terms, so I need a AND gate, sorry, OR gate. So this is one OR gate and the number of inputs is 4. That means number of input is 4. Okay, so now one comes from here, another comes from here, third input comes from here, and the fourth input comes from here. Okay, I think I have done this, and now I need an output pin here. Okay, now let's see, all are 0, all are 0, and now let's say this person wants the light on. Yeah, so this light has been on. Now this person wants the light on. Now this person wants the light on and becomes on. And now let's say the light is on, but this person don't want that, so light becomes off. And this person wants the light off, yeah, this light becomes off. And now the second person wants the light on and the light becomes on. So I think this circuit works and all the three persons are happy. Now can I simplify this circuit? I don't know, using K-map. Let's see, can I simplify this circuit? If I can, then I can use some logic gates, some less logic gates. So let's say x2 x3 and this is x1. Okay, so 0 0 0 1 1 1 1 0 and 0 1. Let's see, so 0 1 1 0 0 0 1 1 0, then 1 0 0 1. So this is actually the K map. I have made the K map, and I think no, I can't make any pair here. I think I can't make any pair. No, I think this is the, I can't reduce the logic gates less than this, so I think I can't reduce the logic gates because it is the minimum. I can't make any pair in the K map. Okay, so now let's try to make this kind of multiplexer. So what this is telling me, this multiplexer, that I mean what the multiplexer do, that means design a circuit that produces an output that has the same value as either x1 or x2. Okay, so S is working like a switch. That means if S is 0, then the output is x1, and if x is equal to 1, then the output is, let's say, x2. So this is actually the multiplexer. So how I can make this thing? That means here S is the controller. Okay, so it will give the control. I think I can use some AND gate. How I can do this? Let's see. Let me go here. I think I can do this thing with AND gate. Let's see. Let's say I have a here, and let's say this is the controller S. Let's say this is S, the controller, and this is one input x1 who wants the access. Oh, sorry, x1. Oh, I have been used x1 before, so let's say this is x5. Okay, let's say this is x4 because I have already used x1 here, so let's make it not x1, let's make it A. So A wants the control, so I have to change it here. So let's say this is A and this is B. Okay, so now let's see. First let's work with B. Let's say this is not A, this is V. Okay, so now what is the problem? The problem is when S will become on, then the output will become B. That means the B will get the access when S is equal to 1. Okay, so how I can do this? Let me connect this thing here and let's see what happens. So I have connected here, and let me put an output here. Okay, so now S is off, so whatever the B is, he will not get the access because you can see that the output is not changing. But when S is equal to 1, now B can change the output. That means when S is 0, no effect of B on the output, and when S is 1, now B can take effect. Okay, Now let's take a NOT gate here and make a wiring. Now let's take another AND gate and put it here. Okay, now let's take another input for A. So this is actually A, and I have to put it here. And now let's see what will be the output. So let's say this is actually the output. So when S is 0, A will get the control. So let's see. So when S is 0, you can see A can make effect on the output. But when S is 1, you can see I can change A, but nothing happens in the output. Okay, so I think I have made the circuit, but I have two outputs here, but I need to make one output. So let me delete two outputs here. And then what can I do? As A and B is independent, and when B is on, B get the permission, A will not, and when A will get the permission, B will not. So I can do that. I will add an AND gate here, OR gate here, and now let's connect a output here. Okay, now let's see. So when S is equal to 0, A will get the control, and you can see A becomes 1, output becomes 1. A becomes 0, output becomes 0. Now S is equal to 1, that means P is now gets the control. So P becomes 0, this becomes 0. B becomes 1, this becomes 1. If I change A, you can see output is not changing because A is not getting the control. And when I will make S is equal to 0, then A will get the access, and B can't change the output. B cannot change the output. So this actually multiplexer is doing this thing. Okay, so now I asked ChatGPT what can I do next. So it told me to work with priority switch. So what is actually priority switch? I think this is interesting. This means that S3 has the greater priority, it is the superior, than S2, then S1. So if S3 wants the switch on, light will be on, and if S3 doesn't want, then the decision will be on S2. If S2 wants, the light will be on, and if S2 doesn't want that, the light will be off. And if S2 wants, the light will be off, and now S1 will get the decision. So how I can do this? That means if S3 wants that light will be on, S2 and S3, no one have the ability to make that light off. Similarly, if S2 wants that the light will be on, S1 don't have any permission to make this light off. Okay, so how I can do this? Let's see. So S3 is the boss here. So if he wants the light on, light will be on. And when S3 will press 1, it will blocks S2 and S1. So how I can do this? I will make a NOT gate here, and then I will block the permission of S2, and again I will block the permission of S1. So you can see that if S3 is 1, S3 this thing will become 0, and you can see that this thing will also become 0. That means S2 and S1 will not get permission, and the light will be on. Now let's say S3 wants that light has switched off, so this will become on and this will become on. So now S2 and S1 will get the permission, but if S2 is on, then S1 will not get the permission. That means, so it will blocks the permission of S1. Okay, so I think I have to make the logic circuit like this. So let's make that. So let me go here, go some below. Okay, now I should have 3 inputs here. Okay, 3 inputs. So this is S1, this is S2, this is S2, and this is S3. Okay, so now let's say this is S1 and I have to give a NOT gate here. Let me make it to the south. Oops. Okay, and I have to, for permission, I will make an AND gate here. Okay, so now, and this AND gate will have 3 inputs. Okay, this AND gate has 3 inputs and this AND gate has 2 inputs. So when S1 is on, let's say S1 is on, it will blocks the permission for S2. It will not give permission S2 to take his action, and again it will blocks S1 or sorry, I think this is I think this is S3. It's superior S2 and this is actually S1. Yeah, now I think it's perfect. This is S3 and this is S1. Okay, and so S3 will again block S3 also. Okay, okay, so I think it should work. And when S3 is off, then S2 and S1 will get the, sorry, when S3 is off, then S2 and S1 will get the permission. But if S2 is on, now it will block the permission for S1. So now it will block the permission for S1, so S1 can now take the action. So let's see, if S3 is on, then S2 cannot make any change to the output, and S1 can't also make any change. But if S3 is 0, now if S2 is on, now S1 cannot make any change to the output. But if S2 is 0, now S1 can change to the output. Now I will make all the outputs to a OR gate. The input pin is 3. Let's take one from here, let's take another from here, and another from here, and this is the final output. Let's make this thing here. Okay, now let's see, if S3 is 1, the light will be on. S2 cannot change the light, S1 cannot change the light. Now S3 is 0. Now S2 can turn off the light, S2 can turn on the light, but S1 cannot do anything because S2 is blocking S1. And now if S2 is 0, now S1 can take his action. So actually this is the circuit for that. Okay, so now ChatGPT has suggested me to do another thing, that is not this. Where is the ChatGPT? Okay, so ChatGPT has suggested me to make this thing, I mean 4-to-1 multiplexer. So what this will do, that let's say I have 4 user, these are the user, they want the access. Let's say they want the access, or these are the input, let's say, and they want to make change in the output M, and C1 and C2 are the controller, or I can tell them as selector. That means they will control they will give access that which input will can take effect. So when both are 0 0, output is equal to x naught, that means x naught will get the access. 0 1 means x1 will get the access, 1 0 means x2, and 1 1 means x3 will get the access. Okay, so how can I make this thing? Okay, so let's see. So let me come here again, and let's make here first let's make here some selector. Let's say this is, let's say, to the south. Let me copy this and paste it here. Okay, so this is, let's say, S1. Oh, S1 has been used, so let's say select one, cell 1, and this is, let's say, cell 2. Okay, so these are the selectors. So I need AND NOT gate here. This will be towards south, and let me copy paste it again. Okay, so this is okay. Now let's see. When both are 0, let's say oh, it is C1 and C0, right? Oh, okay, no problem. Let's say this is cell 0, that is, let's say, cell 0, and this is, let's say, cell 1. Just naming, that's not the problem. Okay, so when this cell 1 or cell 1 and cell 0 both are 0, oh, 1 0, let's make it 1, and then let's make it 0, and let's make it 1. Okay, now I think there will be no confusion. 1 0. Okay, now when both are 0 0, that means x naught will get the access. That means, let's say, this is x naught, this is, let's say, x naught, and let me take here one AND gate, and this input will be 3. Okay, so now both are 0, that means that will look like this. Now both are 0, so x naught will get the access like this. Okay, so you can see that if x naught is 0, output is 0, x naught is 1, output is 1. That means x naught can take the effect here. Okay, now 0 1, that means this is 0 and this is 1, and now another, let's say this, let me copy and paste it here. Okay, let me delete it, and let me copy it and paste it here. So I will take it from here and take it from here, because you see, when this is 0 and this is 0 and this is 1, these two pins are high. That means this will activate the AND gate. This will give the permission to this input. Let's say this is, x1. So we can see now that when this is 0 and this is 1, this is 0 and this is 1, the AND gate has been get the permission. This x4 has get the permission. Now if I make it 1, this will become 1. If I make it 0, this will become 0. But why this is not x1? This should be x1. X1, there exists x1. Okay, so let's make it xx1. Okay, now when 1 0, I mean this is 1 and this is 0. Now I have to take another AND gate like this, and now I will input those lines which are high. So this AND gate will get the access, and it will give the access to the input, and let's make this input xx2. And okay, so now you can see that if I press 1, output becomes 1, press 0, output becomes 0. Again, let me copy this thing and paste it here. And now the case is both are 1. That means this is 1 and this will be also becomes 1, and I will take the line where the pins are high. That means this output pin will be activated, and now I will take an input and I will connect it here. So now you can see that, let's say this is xx3. So now if this is 1, output is 1. If this is 0, output is 0. Okay, so now I will add here one OR gate. The input will be 4, and I will take all the pins. I will connect all the pins here like this, and then I will connect an output here. Okay, so now let's see. When 0 0, this will get the access. So if I make it 1, this will become 1. If I make it 0, this will become 0. And if I connect this, or if I connect this, nothing can change the output. Now if I make 0 1, now this will get the access. So pressing it, you can see that the output is changing by pressing this input. And if I press it, nothing happens. If I press this, nothing happens. Okay, now 1 0 means this will get the access, and you can see this is changing. If I press this, nothing happens, nothing happens, nothing happens. And if both are 1, this will get the access. You can see the output is changing, and nothing happens, nothing happens, nothing happens. So this is 4-to-1 multiplexer, and I hope that I can make 8-to-1 multiplexer also. I think I should I need more circuits, but I expect that the logic will be same. Okay, so now ChatGPT has suggested me to make a demultiplexer. Okay, so let's make a demultiplexer now. Okay, so the demultiplexer is, again, here is some controller or selectors. It is the controller. So what this controller will do, S1 and S0, let's say I have some data, let's say this is T, and let's say I have some output. Let's say this is not let's say this is Y0, Y1, Y2 and Y3. So I have 4 outputs, or we can say that we have 4 channels. So demultiplexer, what this demultiplexer do, that when S1 and S2 is 0 0, then the input will be connected with the Y0. That means this Y0, I mean this y0 will be this y0 will take the input, and when s1 and s0 is 0 1, then the y1, this will take the input, and when 1 0, then this channel will be activated. That means y2 will take the data or the bit, and when it is 1 1, then the last channel will take the bit. You can see y3 is equal to d, and the rest of the thing is 0. Well, so how I can make this, let's see. So that means okay, let's see. So first I have to do the same thing. I mean, I have let me copy this thing because I need this again. Copy, and then let's go below and paste it here. Okay, I think that's good. And now let's make some name. Let's say this is ss1, and let's say this is ss0. Okay, now let's see. I have a data. Let's say this is the data, which I will call D. Okay, so this is D, and let's take one AND gate. Okay, so first of all, when it is 0 0, then y0 will be equal to D. Okay, so let's do that thing. So let me activate this AND gate. Let's say the input is 3. Okay, so when s1 0, s0 is also 0, then you can see that these are 1, the bright ones are 1, and you have to connect this thing with the bright ones to activate this path. And now let's connect this D with this, and this is my output. Let's name it y0. So this is y0. Okay, so that means when both are 0, when both are 0, when both are 0, then the output, that the y0, I mean the first output, will be D. Okay, so let's see. Now both are 0 0, so D is equal to 1, output is 1. D 0, output is 0. Okay, looks good. And then let's again copy this thing and paste it. So now we will make the second output, which will become y1. And when 0 and 1, that means s1 is 0 and s0 is 1, then we have to activate this path. So let's connect it with the brighter ones, and then connect this D with this one. Okay, now let's see. Yeah, so now D is equal to 1, this y1 is 1, and you can see that if I change this D, this y0 is not changing, only y1 is changing. Okay, now let's make this thing 1 0. So 1 1, then 0. So when it is 1 0, the input will become the y2. Okay, so I have to make another AND gate, and I will take one output here, and I will name this output y2, and then I will connect it with the brighter ones. I mean one with this and another with this, and I will take one D and I will connect it here. Now let's see. If I click D, y2 is changing, but these two are not changing. Similarly, 1 1 means y3 will be equal to D, Okay, so let's see. let me let me copy this thing and paste it here. This will become this, oh sorry, this will become y3. Then oh, I have to make both the selectors 1. Then let's connect it with the brighter one to activate this channel, and then I will connect this T with this. Okay, so now let's see. So when both are 0, this path is activated. Let me check. Yeah, so y naught is working. Now if 0 1, this path is activated. So yeah, y1 is changing. When 1 0, then y2 is activated. So yeah, so that's working. Then when 1 1, then y3 should be activated. So let's see. Yeah, only y3 is working. So thus we can make a 1 to 4 demultiplexer.